Formulas based on current electricity. Electric current I is equal to charge by time. I is equal to Q by T. As Q is equal to number of electrons, so I is equal to NE by T. In case of an electron revolving in a circle of radius r with speed v, period of revolution of the electron is T is equal to 2 pi r by nu. Frequency of revolution nu is equal to 1 by T is equal to v by 2 pi r. So current I is equal to E into V is equal to E into V by 2 pi r. Ohm's law R is equal to V by I, or V is equal to IR. Resistance of uniform conductor R is equal to rho into L by A. Resistivity of a specific resistance rho is equal to RA by L. Conductance is equal to 1 by R. Conductivity is equal to 1 by resistivity. So sigma is equal to 1 by rho is equal to L by RA. Current density is equal to current by area, or J is equal to I by A. Current in terms of drift velocity I is equal to En into A into Vd. Current density J is equal to En into Vd. Number of atoms in 1 gram of atomic mass of an element, N Avogadro number is equal to 6.023 into 10 power 23. In terms of relaxation time, tau, resistance R is equal to ml by pi e square tau into A, and rho is equal to m by n e square tau. Relation between current density and electric field, J is equal to sigma E, or E is equal to rho into J. Mobility mu is equal to Vd by E is equal to Q tau by M. Electric current I is equal to ENA Vd is equal to ENA mu E. Conductivity of a metallic conductor, sigma is equal to Ne mu E. Conductivity of a semiconductor, sigma is equal to Ne mu E plus rho E mu N. Temperature coefficient of resistance, alpha is equal to R2 minus R1 by R1 into T2 minus T1. If T1 is equal to 0 degrees and T2 is equal to T degrees, then alpha is equal to RT minus R0 by R0 into T. RT is equal to R0 into 1 plus alpha T. The equivalent resistance Rs of a number of resistance connected in series. Rs is equal to R1 plus R2 plus R3 plus so on. The equivalent resistance R rho of a number of resistance connected in parallel is 1 by R rho is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. For two resistors in parallel, currents through the two resistors will be I1 is equal to R2 by R1 plus R2 into I. I2 is equal to R2I by R1 plus R2. EMF a cell epsilon is equal to W by Q. For a cell of internal resistance R, the EMF is epsilon is equal to V plus IR. So I into R plus R. Terminal potential difference of the cell V is equal to IR is equal to epsilon R by R plus R. Terminal potential difference when a current is being drawn from the cell V is equal to epsilon minus IR. Terminal potential difference when the cell is being charged V is equal to epsilon plus IR. Internal resistance of a cell R is equal to capital R into epsilon minus V by V. For n cells in series, I is equal to n epsilon by R plus nR. For n cells in parallel, I is equal to n epsilon by nR plus R. For a mixed grouping, I is equal to mn epsilon by mr plus nr. For the maximum current, external resistance must be equal to the total internal resistance. Nr by m is equal to R. So nr is equal to mr. Heat powered by the electric current H is equal to I square RT joules is equal to I square RT by 1.48 calories. Or H is equal to V into I into T joules or VIT by 4.18 calories. Electric power P is equal to W by T is equal to V into I is equal to I square R is equal to V square by R. Electric energy W is equal to P into T is equal to V into I into T is equal to I square R into T. As Kirchhoff laws, sigma I is equal to 0. Total incoming current is equal to total outgoing current. Sigma epsilon is equal to sigma IR. For comparing EMFs of two cells, epsilon 2 by epsilon 1 is equal to I2 by I1. For measuring internal resistance of a cell, R is equal to L1 minus L2 by L2 into R. Potential gradient of the potentiometer wire K is equal to V by L. Unknown EMF balanced against length L, epsilon is equal to K into L. For a balanced Wheatstone bridge, P by Q is equal to R by S. If X is unknown resistance, P by Q is equal to R by X, or X is equal to RQ by P. In a slide wire bridge, if balance point is obtained at L centimeters from the zero end, and P by Q is equal to R by X is equal to L by 100 minus L, or X is equal to 100 minus L by L into R.